Hi everyone, so this is still chapter 4 and we're going to talk about correlations and also experimental design. So as you probably remember from statistics, for a correlation, our correlation coefficient ranges from -1 to +1, and a 0 would indicate that there is no correlation. If we do have a significant correlation, we fall typically in one of three categories with the correlation. It could either be a positive, negative, or curvilinear correlation. So as you can see here on the left, we have an example of a positive linear relationship. And the example here is the number of years we spent in school and salary expectations. So as one goes up, the other one also increases. Another example would be higher grades in college would also be associated with higher acceptance rates into graduate school. Then on the right, we have an example of a negative linear relationship. The example here is as self-esteem goes up, paranoia tends to decrease actually. Another example would be as exercise increases, stress actually decreases. And then on the left here, we have an example of a curvilinear relationship. One really great example is test anxiety and test performance. So we know that if somebody has a little bit of test anxiety, right, it shows that they care. Typically, that's associated with higher grades. But then it kind of plateaus and it gets to a point where test anxiety is so strong that somebody is almost paralyzed that they can't perform well on the exam anymore. So a little bit of test anxiety is good because it actually seems to increase test performance. But then if it gets too much, it's actually detrimental to your test performance. And then on the right, you see an example of where we have a zero correlation, so something where your correlation coefficient will actually be close to 0. And a positive linear relationship would be associated with a positive R value, so anything ranging from probably 0.3 to 1. And a negative linear relationship would be associated with a negative correlation coefficient, so you would have a negative number. And you actually cannot detect a curvilinear relationship using a Pearson R analysis. You have to use a different kind of analysis. If your analysis is close to 0, right, most likely there's no relationship between the variables. An example here would be height and GPA, right? There's no correlation between these two variables. Okay, so let's go over a couple of examples. And you have to identify what type of a relationship it is. So increased alcohol use is associated with increased smoking. So I'll give you a second to think about this. And this, of course, would be an example of a positive linear relationship. Number 2, as health awareness goes up, smoking behavior goes down. And this, of course, would be an example of a negative correlation. So as one goes up, the other one goes down. Then a third example would be a student with many absences has lower grades on the exam. So as the number of absences goes up, the grades go down. This would also be an example of a negative correlation. And then last but not least, we have customer satisfaction increases the more cheerful the staff is, but then decreases if the cheerfulness is too high. And this would be an example of a curvilinear relationship, right? Because we have, probably also you've experienced this. If a staff in a store is very friendly, right, usually you feel more satisfied with your experience. However, if they're obnoxiously cheerful and follow you around, then probably your satisfaction will be lower. So it seems to plateau at some point, and then satisfaction actually goes down. All right, but one big problem, of course, with all correlations is that we're just observing behavior. We're not manipulating anything. And a correlation really only establishes that there is a relationship, but it's kind of the chicken and the egg question, right? What comes first? And with a correlation, we simply cannot say, right? For instance, if you take depression scores and sleeplessness, we do know that there's a positive correlation, but we really can't say that one causes the other, right? Because we don't know what happened first. So what is one thing that we cannot do with non-experimental research, right? With correlational research, we can never infer cause and effect. So we can never infer causality. We don't know which one caused what. So it's kind of the chicken and the egg question. To answer the question of what's the cause and what's the effect, we do need to conduct an experiment. And the reason why that is because with a correlation, we don't know if, in our example here, the depression causes the insomnia or the insomnia causes the depression. So that's a real limitation. And if we want to find out which causes which, we need to do an experiment. But let's first look at why, with correlations, we simply cannot infer causation. So there obviously is this directionality problem, right? We don't know what causes what. And there's always the problem of intervening variables. It's quite possible that it's actually not the depression that causes the insomnia, but rather it's a different behavior. So it could be that your depression actually causes you to stay up late and watch TV. And we do know that the use of technology right before you go to bed actually interferes with sleep. Therefore, it's not the depression that's causing your sleeplessness, but it's actually the TV watching. Another problem, of course, is that our dependent variable is really changed by a third variable altogether. So it could be that, yes, you're depressed, and maybe as a result of your depression, you fight a lot with your friends or your loved ones, and that's causing your sleeplessness. So it's not actually the depression that's causing the sleeplessness, but rather it's something else. In this case, the arguing with a loved one that's causing your insomnia. So a third variable is basically adversely affecting the relationship of your independent variable and your dependent variable. And that's something that we always want to be aware of, because you don't want a third variable to actually be causing your change in the dependent variable. So we can never infer causality. To do that, we really need to manipulate the variables. So we have to do an experiment. But, obviously there's some ethical concerns here. But what we would have to do theoretically to figure out what comes first, is the lack of sleep causing you to be depressed. We could do a study where we manipulate the amount of sleep that people receive, and then we can observe over a period of time if actually as a result of sleep deprivation they would actually if they would experience depression. Another way that you could test this is that you would test if depression causes insomnia. So you would induce depression, obviously very unethical here, but you could potentially decrease the amount of serotonin in somebody's brain, which would cause them to be depressed. And then you could see if you're inducing depression, now you would also be seeing changes in their sleep pattern. So depression, then we could say, would cause the insomnia. Obviously, these things would be not ethical to do as a experiment, but you get the idea of what I mean. Okay, so for an experimental design, right, we have some important components that we need to talk about. We, of course, have our independent variable, the variable that we're manipulating. It's independent because it does not depend on anything else in the experiment. As experimenters, it's our job to manipulate that. So that's what you have control over as the experimenter. The dependent variable, on the other hand, is the variable that we're measuring, so our outcome variable. Of course, that's the other really crucial part of our experiment. And we're hoping that our change in the dependent variable is the result of the manipulation of the independent variable, right? And you can directly observe if you're manipulating the independent variable one way, you get this outcome. If you're manipulating it a different way, you get a different outcome in a dependent variable. All right, so then we also have three other things that we need to be aware of. Control, random assignment, and confounding variables. Obviously, those are not variables that we're really interested in. They're not the main focus, but they're still critical components because they actually influence the validity of an experiment. So we really need to be aware of them. Okay, so the first thing we need to talk about is control, right? In experimental design, we do have a lot of control, and that's important because it helps us stabilize the variables. So we need to make sure through control that we don't have some irrelevant variable that's interfering with either our independent or dependent variable. Now, you probably have seen some examples of experimental studies where you're in a laboratory, it's a very artificial setting, not like the real world. You're manipulating one thing and you do see an effect in the dependent variable. But typically, control you have to kind of balance, right? We do want to have control over the variables that we're manipulating, our independent variable, and we want to control the setting to make sure that everybody experiences the same thing while they're in the study. But you also have to keep in mind that if it's too artificial, right, it usually hurts generalizability because it's not like the real world. And if we don't really have the ability to generalize from our results to the general population that we're interested in, right, the study typically lacks external validity, a concept that we'll talk about a little bit more later in the chapter. So you kind of need to balance how much control is necessary, but you also need to keep in mind that you don't want your study to be too artificial because then you really can't make any inferences about what would happen in the real world. Okay, randomization. So randomization, of course, is an important concept in research because we want to make sure that we randomly assign people to different groups. So there's not any consistent differences between the two different conditions that we're assigning people to. You don't want to pick, one personality type to always be in one condition and one personality type to always be in the other condition, right? That would be a consistent factor that would, of course, influence what's happening with your variables. Obviously, it's impossible to control everything, but as researchers, it's our job to control what we can control. So you want to take each participant, maybe draw a marble out of a little bag and say, okay, based on the marble, you're going to be this condition. You don't want to look at them and, decide based on what you're kind of perceiving them to be and assign them to different conditions. It needs to be something random. And the idea behind that is that if we're randomly assigning them to groups, right, we're also controlling kind of random variables that we're really not interested in, but that might still influence your study. So we want to make sure that any kind of uncontrolled variables are equally represented among the experimental conditions. So maybe if you have somebody coming in with a cold, right, chances are that through random assignment, right, if you have a large enough sample, that 50% of people who had colds will be in one condition and 50% would have been in the other condition. So it really evens itself out and doesn't necessarily influence the outcome of the experiment. And also, one more thing to say about randomization is that it's really a critical part of the experimental method because it eliminates the consistent effect of extraneous variables. So you're basically eliminating the possibility of a third variable causing the change in the dependent variable rather than your independent variable. Also, lastly, about random assign, you have to make sure that you actually collect enough data, right? So you want to have a large enough data so random assignment actually, does even itself out. But if you have very small n, then chances are that there is something consistently different about those different groups that you're assigning. So you want to have a large enough sample, and then you want to really randomly assign people to one condition or the other. Okay, and then lastly, we have our confounding variables, also sometimes called our third variables. So that would be something that systematically influences the independent variable that's not controlled or randomized. So you really want to make sure that you're controlling for any kind of confounding variables, in your experiment to make sure that they're not actually driving the result that you're seeing in your dependent variable. So you want to make sure through randomization that you're systematically spreading them out among the different conditions. and that it's not consistently just in one condition. All right, so this would be it about correlational and experimental design.